Session 10, real-time data visualization and data analysis. We have Derek Moore, who's a cloud architect and data engineer who you heard from in the last session. We have Edward Moa. He is a graduate student in ecology, getting his PhD. And we have Pete McCloskey. He's from the Penn State Innovation Lab for Current and Emerging Threats. He's the lead AI engineer for PlantVillage, specializing in developing computer vision systems to help fight food insecurity. These include systems for crop disease diagnosis, pest damage, recognition on crops, and food recognition. So welcome.
Okay, I think I'm up first. Can you go to the next slide, please? So to recap, we use the panels for doing data quality control. These we just saw. These let us select data out by date range, by country. We can filter by data quality type, whether it was confirmed data, suspect data, data that was part of a training seminar, for example. We can filter by usually by data type. Does it have a disease? Does it not have a disease? So on. Again, these panels are used for deep dives on data quality control on data collected by Nuru. This example is for locust surveys, but we have these as well for wheat and coffee and maize and cassava and other plants that we develop. Next slide, please. One of the things we found as part of doing data control was the importance of images. So during the locust crisis, we found that we were seeing records that were coming in. We initially did not require images, and we saw very kind of suspect looking data, but we wanted to confirm that these records were legitimate. So we started requiring images. And then we found some really interesting things. People really wanted to submit bad data. So they would take a locust and they would take it back to a lab and they'd pin it to a piece of paper and take a picture with it. Or they would take it back to their home and take a picture with it on a carpet. Or on the image on the right, it's a picture of a computer monitor. You can actually see the individual pixels there. So we found it's really, really important to get images as part of a survey, whether it's for locusts or for crops. There's a lot of information that we can see in crop images as well. So often when we're taking surveys, we encourage people to take zoomed in pictures of specific parts of plants, but also a wide image so we can see the farm, so we can see what's going on with the soil, what's going on with the landscape. There's a lot of extra information that human reviewers can extract as well. So what we find is data quality control is often a combination of human review and then AI tools to try to mark data as suspect, or automation tools to try to pull in supplemental data about temperature, rainfall, soil type, so on, to supplement the human review. And often prepare to be surprised, because we had no idea people were going to do these sorts of things during the locust crisis, for example. So next slide, please. One of the tools that we use on the back end a lot is an open source tool called Apache Airflow, which is an open source job scheduling system. And this does a lot of our kind of tedious automated tasks. So for example, in the previous session, we talked about geocoding surveys. So when a survey comes in, we take its latitude and we launch it in longitude, and we query a database to get the street address, city, state, country, county. We use Airflow to do that. We also use Airflow to pull in supplemental data about the land cover classification, the soil type, soil moisture, recent rainfall data. That can be used, again, to supplement data quality control. If we see a lot of agricultural surveys, but they're coming from a city, we know, okay, that's either someone's GPS is broken. We found some bugs in the app where it was using the wrong location to sync data, or it might indicate there was a training session. So if we see, for example, 300 records coming in a 2-day period from a particular hotel in Lagos, we know, okay, there's a training session there, but we need the data to do that, and we use Airflow to pull a lot of those in. In terms of outreach, we also use Airflow to generate maps. So we generate rainfall maps every day for multiple countries, and then all the counties in Kenya. We use Airflow to run that. So anything that we can automate, we use Airflow to do that. We have computer vision models that Pete developed to look at wheat rust diseases and also for locusts. So for the locust surveys that would come in, we require images, and those models could tag the image as being sort of a hopper, or basically is it a juvenile or an adult locust, and the computer vision models were all triggered by Airflow. So Airflow kind of sits at the heart of a lot of our backend processes and is really integral to automating data quality control. Next slide, please. So Airflow, I'm not going to go too deep into the programming aspect, but it has these scripts that are called DAGs. So you can see an example of one in the upper left. This is one that we developed for locusts, where when a locust survey comes in, we want to get some supplemental information. We want to know the land cover classification, that's LCC. We want to get the soil sandiness and the soil moisture. And we do that automatically for every record that comes in. Periodic, I think every 5 minutes, we run a data quality check. So some records come in and the user's phone's GPS wasn't able to get a GPS lock, and so we don't have the latitude and longitude. Those records are not useful to us. We don't know where the record was taken. We can't do anything with it, so we just soft delete those records. If we can identify training data automatically, we automatically mark those records as trained. We pull in supplemental data. We convert images to different formats that have broader compatibility. So these are just deep dives in some of the examples of the data quality control that you can do with Airflow. Next slide, please. Speaking a little bit more about data management, well, we need to pull in all the supplemental data. We get all this data from various third-party data providers, the Climate Hazard Center at UC Santa Barbara, NASA Surveyor. Those come in as geotiffs. And so one of the tasks we have in Airflow is to convert them into what's called a cloud optimized geotiff, which is just a geotiff format that works better in the cloud. And then we can develop APIs to easily query that data. So this is an example of soil moisture. So you can see the rectangle, the black and white rectangle on the left is soil moisture data that we get from NASA. I just overlaid a map of Africa for reference. And then the API at the top just queries that. We get back data on the bottom. So we can have data analysts use this to pull in point data. We have Airflow use this to populate our database. And using Amazon Web Services, we can very easily set up these APIs. Next slide, please. As I mentioned, we also do this for automated map dissemination. So I'm not going to go through the image on the left, but that's just showing all the different kinds of maps that we produce: rainfall maps, greening maps for the pastoralist counties. And again, these things pull in data from third-party providers. We convert them to cloud-optimized geotiffs so that they're easier to work with. We run them through scripts in either Python or in R, and then we mail the maps out. And this just runs automatically. This is really, David, a couple of minutes ago, mentioned that he has very ambitious plans to scale up PlantVillage, and the only way we're going to be able to do that is through automation. So we try to automate all the data collection and dissemination that we possibly can. Next slide, please. Okay, and with that, I'm going to turn it over to Pete.
Thanks, Derek. So I'll try not to repeat much about the panel since Derek's covered them a couple times now. But so just from sort of the computer vision AI perspective, the panels are really, really critical for us to be able to monitor our models in production. So when we're developing the models, we go through a pretty rigorous validation process to make sure that they're making accurate predictions and accurate diagnoses. But then oftentimes when you put those models into production, it's very hard to keep up and continually monitor that accuracy. But the panels are the main way that we are able to do that. So specifically on this cassava panel, we have on the bottom left corner of the slide is sort of two images. The first one is actually just an image that we asked the user to take of the field. So we're not expecting to have any diagnosis there, but the image to the right of it where you see just the single leaf, which looks like it has mosaic disease. This allows me as a machine learning engineer to see the actual individual leaf that the user was looking at and the model was looking at. And then just below that, you can see the detected diseases or the detected diagnosis. And you can see that it's cassava mosaic disease. And then in the parentheses there, the numbers are actually confidence values for those detections that have the cassava mosaic labeled. And so this allows me to see sort of in real time how the model is performing on various sets of symptoms. And this is really critical for me to be able to understand where the model is performing well, and we can kind of say, okay, that's good, and but more importantly, where it's performing poorly. And then, can you go to the next slide, please, Melissa? When we find, so this is just a zoomed in version of that same leaf in the expert, the detected diagnosis below it. But what this is showing here is actually the ability that we give experts the ability to assign a diagnosis. So they can see this leaf, they can see the detections, and then they can come in and assign their own diagnosis. And this allows us to compare with what the model's predicting and what the expert diagnosed. And then, Calista, can you go to the next slide, please? With the expert diagnosing the leaves and also the model, we can then generate what's called confusion matrices using a tool called Superset that Derek mentioned earlier, and Edward will touch on a bit more later on. But what we have here is the confusion matrix, which shows on the rows the expert diagnosis, and then the columns the model diagnosis. So what we can see here is that for 13 of the plants that the model predicted to have CBSD, the expert confirmed this as CBSD. But if you look over two cells to the right, you can see that the model predicted 3 plants to have cassava mosaic disease, but the expert confirmed or assigned the diagnosis for those plants to be cassava brown streak disease. And so we can take these expert and model diagnoses and find where they don't line up, like in this case, the model predicted mosaic, but the expert confirmed brown streak. And we can take that exact image, annotate it the way that we do with all of our training data, and then feed it back into the model. And this allows us to do a process called active learning, where we actively integrate additional data that improves the model over time. And then we can just continually improve the model and find as it expands to other locations where we might see a variation in symptoms due to different varieties grown in, for example, Southeast Asia for cassava versus sub-Saharan Africa, we might expect to see different symptoms. And so this allows us to monitor our models in production and also improve them through the active learning process. Calista, can you go to the next slide, please? So this is just another example of one of the panels that we have. In this case, it's for wheat surveys. And I just wanted to add this slide here specifically to show that the previous example with the cassava surveys is what's called an object detection model running offline on the phone. And so that's where the list of the numbers, the 99.8 and the cassava mosaic disease, those are the boxes being detected. This is a slightly different model. It's called a semantic segmentation model. And so this one, if you see on the right, on the left side here is the original image of that somebody submitted. It looks like actually this is a record from Dave Hodgson, a Rust expert from CIMMYT, and the survey was done in Nepal. And then on the right side, you can see the segmentation API status was successful. And then the segmentation predictions are listed there. So the white pixels represent the background. The green pixels represent what the model's predicted to be part of the wheat leaf. And then it's hard to see because the image is small. Actually, Calista, can you go next? And then actually one more too. So here's a much more zoomed in example. So you can see the red pixels are where the model's predicted the wheat leaf has some stem rust. And so this is, again, a incredibly useful tool for me to be able to visualize the model predictions in production and understand that for this specific example, the wheat leaf actually has some leaf rust. And so this helps me understand that maybe the model is thinking that the leaf rust is stem rust. This is understandable because leaf rust and stem rust look very similar. But just the way that we have with the cassava and actually all of our panels, we give the ability for experts to assign a diagnosis themselves, in this case, again, leaf rust. And then we can take that data, just like we do for the cassava, annotate it, feed it back into the model, and make improvements over time. And I think with that, I'll hand it off to Edward.
Thank you, Pete. Just like my partners have talked about, we have sort of two tools that we primarily use for visualizing data: the AG Observatory, and also we have the Apache Superset that Derek talked about that we can also use to visualize data. So the AG Observatory is sort of the custom-built platform that we can use to visualize data from farms. So we can see farm surveys, we can see photos, we can also pull in data from satellites. And so we have soil moisture coming from NASA. We also have UNFAO WAPO data where we can see sort of moisture and other information as well. We also have the African rainfall estimation. So we can sort of see the rainfall estimation for a particular farm where a survey is coming from. So we can see if the farm is getting enough rains or is it not getting enough rains. And we can also see our commercial partners there. So the AG Observatory is a really great tool that our team in the field can quickly go onto the platform and be able to see what's happening on this farm and sort of like in the long run, how the soil moisture over time, and also how is the rainfall over time for the particular farm, as well as how is the data coming in for this particular farm. So it's a great tool that enable our field agents to be able to give accurate and information-driven advice to farmers. Next slide, please. So like I talked about before, the AG Observatory is a custom-built data visualization platform. And as you can see on the left, you can see sort of like the soil moisture information. On the right, actually, top right, you can see the soil moisture information, as well as you can see some photos coming in from the farm. We also have other data collection that is also coming in from the carbon capture system that we are working on as well. You can also see the above ground biomass of the farm. You can also see information about the effective rainfall that I talked about before. And so you can see whether or not is the farm getting enough rains or is it not getting enough rain. So again, this is a really great platform that enables our team to understand, for example, is this farm getting enough rain? And what information should I give to this farmer? Should this farmer be practicing mulching? Is it necessary for this farmer to, say, do irrigation or not, based on, for example, the amount of rainfall that the farmer is getting, as the person can see from the platform. Next slide, please. So we also, as Derek talked about before and multiple times, there's also Superset. And so you can think of the Superset as sort of like the ODK of data collection. But on this side, on the flip side, for data visualization. So the Nuru is custom built by the team. It has set data structure, and in order to add data to the Nuru, you will have to go through development team. You have to make tickets and sort of all that process. On the other hand, with the ODK, you can quickly build surveys and collect data almost immediately in the same day. The same thing happens with the superset. The supersets, you can go onto the Apache platform and build custom data visualization almost instantly. This is not in-house built. It's an open source platform, and so you don't have to go through our engineers in order to build dashboard or something like that. So that's kind of how it is. The cumulative surveys that are coming in from the platform, example of some of the things that you can visualize. You can also see daily activities used by the app, and so there's many things that you can do. You can do almost anything that you want to look at for your data. So if you want to see, say, how much if you have different users that are collecting data in the field for you, and you want to see which user is collecting more data, you can use Superset to visualize that. If you want to see, if let's say you're collecting data from 10 different counties and you want to see which county you have more data coming from, you can use Superset to sort of visualize that data. You won't see that in the Ag Observatory. You might not see that in the Ag Observatory, but you can create a custom data visualization in Superset to be able to visualize that. Next slide, please. So what are sort of the lesson learned from using Superset? I've used Superset myself to visualize some data. I think that one of the important things and the benefits of Superset is that you can easily build and visualize charts, and you can build charts without coding. And I think not everybody has the coding skills or programming skills. And so it's important to have another option if you don't have an engineer on your team to be able to program these dashboards for you. You can use Superset easily to build these dashboards. And again, you don't need a computer scientist or a programmer to be able to do that. And so that is a great tool if you don't have any programming skills. And also the other benefit of the Superset is that it is connected directly to sort of our backend infrastructure, and so it can directly pull data from the backend and work with already existing data infrastructure. So you can build custom visualization for, say, even data coming in from Nuru or data coming in from ODK if you were able to connect it that way. Thank you.
Okay, thank you very much. So we've had a few questions come through, and I'll just start with them and go through them. In Ethiopia, a number of major crops are unregistered in PlantVillage Nuru app pellet form. How do you get them registered?
Is this referring to the other diseases section of the app, or I would say that if it's other diseases, probably the dream team member should just contact one of us, and or Surge, and we can add it in. It's very if it's just selecting something from a list, it's very easy to add in.
Okay. So it said major crops are unregistered, so I don't know. I guess, as Derek said, just contact the team and they can help you out. Okay, the second question is related to another question that was asked earlier. When we go to agricultural experts and government stakeholders, if they are not committed to our survey, what can we do? That's kind of a different level than the other people who might not be committed to the survey. So
for verification, we can say that before going to a survey, send correspondence to respondent in advance to explain the objective of your survey. If necessary, fill survey authorization with the authority responsible for the agent to be surveyed. if the purpose of your survey is to improve the living condition of a population, I think you will be well received. Thank you.
Okay, thank you. All right, next question. How can confusion on nutrient deficiency and disease or pest damage accurately be differentiated using models?
So it basically just comes down to adding in those phenotypes to the and labeling them correctly in the model. So I didn't show it in the screenshot of the confusion matrix, but we actually do have nutrient deficiency classes for the cassava, and also there's green mites and red mite classes as well. So we're able to, with those classes incorporated in the model, we're able to distinguish the symptoms from the pest damage, from the nutrient deficiency, from the diseases. And so basically just if we have them in the model and we have the sufficient data labeled correctly, then we're able to accurately recognize them.
Okay, thank you so much. Okay, there's an additional question. Okay, sorry, I'm just reading it to see what it is. Additional to January's question, thank you, Annalise, for your response. I may have missed something because I'm not sure what that's referring to. I think my fellow Dream Team member January was referring to our locality, Kigoma, Tanzania, and that may be extra. That may be an extra answer or have extra answers. I'm not sure what the question is, but maybe you all know. No, okay.
I can just chime in. The question was about what are the other information methods in which this knowledge is delivered to farmers in case they don't have smartphones. And so my response was that we do have a number of other initiatives that we roll out this information to farmers in, one of them being an SMS hotline, which is currently only available in Kenya. We have television and radio programs that are currently running in Kenya, Uganda, and Burkina Faso. And then we also do more manual methods like leaflets, brochures. And then part of the Dream Team model is to utilize the social networks that exist in farming communities already. And so we're able to have one smartphone reach 100 other farmers in their nearby communities. So at the moment, the other initiatives that directly reach farmers, so SMS, television, and radio, are not currently in Tanzania specifically, but we do work along the way to make those partnerships and make that possible.
Okay, perfect. And I see David is also adding to that, typing another answer to that. So thank you very much. Okay, so we have a question for Pete. How can we implement a monitor and improve process in a new location, say here in Honduras for potato early and late blight?
I think the main thing to get sort of up and running when you want to do this improved process is to have the disease experts coming to the panel regularly and confirming the surveys. So if we can get a collection of disease experts, these could even be Dream Team members that have been trained on how to recognize these diseases. If we have them continually coming to the panel and assigning diagnoses to the surveys, it's fairly easy to then use a script that I've developed to just pull down those images. So the main hurdle in getting in any one of these processes up and running in a new location is getting the disease experts with the appropriate knowledge on the panel confirming surveys for us.
Okay, this question is, okay, Winkit is answering it. are the Shamba Shape Up episodes available online yet? So I'm not sure if any of you guys can answer that or if Winkit is taking care of that. If not, I can move on to the next one. Okay, I'll just move on.
Yes, yes, they are available. I'm sure Winkit is going to put in the YouTube page for that.
Okay, yeah. And I think we're going to be hearing more about that later today as well. So, okay, how long will it take for the human experts to give feedback about the uploaded pictures to the farmers and users under the other crop feature?
I think generally our goal is to have feedback within 24 hours. But I know at this point, I don't think we're hitting that yet. But I don't know, I'm not sure. Serge, do you want to add?
Yes, our goal, like you said, our goal is to give the feedback in less than 24 hours, but the last 2 months, we have an exponential growth of our users. So we are a little bit back of replying people to keep the 24 hours. But just to let you know, yesterday we had a discussion about that, and we need to meet with our team and maybe increase our team that and assign people to each region. So that will help us to be able to give our feedback as soon as possible to farmers, because we know when people send their survey, they expect to have a feedback from us, but it's due to our exponential growth the last two months. And also what's going on is we have the season that starts in many regions of the continent and also other places of Asia. So that means we have a really a high number of submissions, but we're working on that and make sure you have your notification as soon as possible. Thank you.
Thank you.
I'm just going to share my screen for 1 second.
Go ahead, please.
So Serge mentioned, this is Superset. Serge mentioned other disease reports. You can see they've really taken off lately. So we're getting a lot of data in, which is fantastic, but it is impacting turnaround time. So.
Great, thank you. Okay, I'm not seeing any more questions specifically about these sessions, but there may be more coming through. Please continue to ask your questions. We have about 10 more minutes before we take a break. I did want to mention in the meantime that there is a WhatsApp group that was created, and maybe somebody can put the link to that in the chat. I know it's been pretty active even today. Again, the slides and the recordings and everything will be posted in the Google Drive in the next couple days. By the end of the week, everything should be there, except for we're getting the slides translated into French and Spanish, and that might take a few more days to get those up. But we're also, like I said, creating a space on the PlantVillage website that's not up yet, but you will all get a link to that as well. And all the videos will be there and all the information, and you will have the ability to continue to ask questions in a Q&A format there. So I just wanted to make those announcements. And if you wanted to follow along with the presentations, the English presentations are available right now for today in the Google Drive. So you would just click on the link to the Google Drive, navigate to May 25th, which is today, and then you should see the PowerPoint presentations there for today's presentations. And I believe session 9 also has the Spanish and French versions in a PDF format. But those again will be translated at a later date. And we've had another question come through in the meantime. What are the major constraints for African farmers to benefit from small and big data? Any proposed strategies to overcome these constraints? Which data are more important for African farmers and why? Do you want me to break those down and answer? You can answer them one by one. That was quite a few. So first of all, what are the major constraints for African farmers to benefit from the small and big data?
I mean, we tend to view the data collection tools we have as sort of a distributed sensor network. We need to know what are the major crops in each country, what are the major pests, what are the major abiotic stressors that they're facing, and we need data from on the ground in order to do that. So that's been a challenge, is getting the data in and getting it reviewed and making sure that it's correct. And then we also sort of, another challenge is distribution of that. So if we see that there's drought being forecast, we need to communicate, well, when should you plant? What kind of mitigation strategies should you use? The Dream Team's been absolutely critical in that. So the SMS networks and iShamba and other mechanisms, I think those are the major constraints that I see. I'd be curious in hearing from, you know, Winked or Mercy or the folks on the ground what they see.
Would anyone else like to share?
Derek, can you repeat your question? Experiencing network problem.
I was very curious to hear from the perspective of the Dream Team members what constraints they have in terms of either getting data, collecting data, or once the team comes up with recommendations, getting those recommendations out to farmers. What's been your experience with that?
Okay, concerning that, I can say that in a way or the other, in order to access that data, sometimes is difficult because some of the communities we have around, they are not that welcoming, they are hostile. So in that, it becomes a bit hard, but in others, it is, they are some of them are very welcoming, and it becomes easy for the team to be able to have that data. For more information, the Dream Team members can be able to give more experience they are having in the field.
Thank you.
Okay, Mesfin, please let us know if we answered your question or if you have any follow-up questions. We had another question in the chat. What are some of the technology adoption challenges that you faced during the early implementation stages of the project in LDCs, is that lesser developed countries? And how did you work to overcome them?
I would say this is not necessarily specific to the early stages. We still face these challenges of smartphone or technology literacy, I think is the term. So basically, a lot of the farmers that we're dealing with are older, and so they're not so literate with how to use smartphones. One of the recurring things I think we've heard about is farmers accidentally deleting the app and not knowing how to reinstall it. So that's sort of an ongoing challenge. And also sometimes low literacy rates, like so we've made a point to have the app do text to speech, so they can sort of walk the farmer through a diagnosis through a verbal method, so that it's available to farmers that are illiterate. I'm not sure if any of the other members, maybe WinKid, Serge, or Romeric, would like to add some challenges that we faced in early adoption.
I guess I'll just jump in. We sort of regularly see issues with data synchronization. There's often, intermittent internet connectivity, and so sometimes data don't get uploaded, or they don't get uploaded completely. So sometimes for surveys, we have sort of the text survey data, but we also have images. And sometimes we get the text data one day, but it might be a few days later until the images get uploaded. That's an ongoing issue that we have. And then there have been issues around phone camera quality and tuning some of the AI models to work better on the phones. There were some overheating issues because some of the phones, the chips in the phones weren't fast enough to run the AI models. So we had to adjust the models and adjust the apps to handle that. And those are issues that are sort of ongoing. We sometimes encounter error issues when we launch into a new country. So we've had models that might work fine in Kenya, and then we deploy them in Nepal, and all of a sudden we uncover data quality problems because there are local variations in crops, and the models have to be retrained.
Yeah. Just to add to that, another issue is maybe the farmer literacy, because when you finish counting your crops and you have the advice in your end, so sometimes we start having the speech coming to read your advice, but because of farmers don't know how to read, so they couldn't really read through this advice and get the knowledge of the advice if they don't have some literacy level. So that's this type of maybe adoptions, but we're working to have Nuru speaking to you all the way down, giving you the advice what you should do. So farmers have the opportunity to listen and not even in the language. And in that, it's coming to another viewpoint, to see if we can have, we know now Google start having some African languages in, so I'm sure developers can integrate that if we work with experts on the ground as well. So to have Nuru giving them the advice and not having them to read everything down. So it's if we move forward, we're going to hit some point, but we're working every time to help the farmers to fully embrace the technology and have the opportunity to learn more.
Thanks very much. We have one final question before we take a short break, and it's related to that question that I just posed, and it is, how have you promoted acceptability and adoption of the technology?
Hi, I want to speak in French. It is possible?
On y va.
OK. Alors, pour favoriser vraiment l'acceptabilité et l'adoption de la technologie, vu que la plupart des producteurs sont des illettrés, on cherche au moins dans la communauté un membre qu'on appelle producteur leader, à qui vraiment on va confier la technologie, qui va passer dans les champs des uns et des autres, essayer de promouvoir la technologie auprès des agriculteurs, leur montrer comment ça marche. Également, on essaie de faire des séances de formation pour vraiment entraîner les producteurs à pouvoir utiliser cette technologie-là. Pour ceux, par exemple, qui n'ont pas les moyens pour avoir accès au téléphone, parce que c'est les téléphones qu'on utilise pour collecter les données, on essaie d'acheter des téléphones qu'on remet à des producteurs, et au fur et à mesure qu'ils utilisent, les autres producteurs également peuvent apprendre directement avec eux et trouver des moyens pour pouvoir payer des téléphones également et épouser l'idée. Voilà. Merci beaucoup. Thank you, Kalista.
Merci. That's the extent of my French. Okay, well, there was one other question. Input quality is important. Have you thought of providing farmers advice on where to get affordable, high quality inputs?
Yes, we do. We help them with the clean seed systems. We also are providing inputs through the USAID project, and then trying to work with local private companies who can help us scale up this as well and establish that the products are very useful for increasing the yield. So one of the main objectives of the Innovation Lab is to work with private companies to enable the scaling up of inputs for farmers. Thanks.
Okay, perfect. So with that, we will take a short 5-minute break. I want to thank our speakers, Derek, Winkit, Romaric, Edward, and Pete. And we'll come back again in about 5 minutes and we will move on to communication. Please continue to ask questions in the Q&A or in the chat, and we will try to get them answered sort of offline, not in a live format. So thank you very much. We'll see you soon.